Hello everyone, welcome back. And today's topic is sampling distribution. I am Sumesh Sadalgi and I'm currently pursuing my bachelor's degree in computer science and artificial intelligence in Sri Venkateswara College of Engineering. Today we are going to discuss about the sampling distribution. If you want to know how to make accurate interferences about an entire population based on a sample, you need to understand the concept of the sampling distribution. In this presentation, we will cover the basics of the sampling distribution, its importance, the central limit theorem, and much more. So let us begin. So let us start with the overview of a sampling distribution. The first one is, what is sampling distribution? A sampling distribution is a probability distribution of a sample statistic based on all possible samples of the same size drawn from the same population. And why is this sampling distribution is important? It is important because it provides a framework for making uh, statistical inferences about a larger population based on a sample with implications across the industries and the fields. And what is the difference between the sampling distribution and the population distribution? While the population distribution describes the characteristics of the entire population, whereas sampling distribution explains the characteristics of the sample. So let us dig in much more to understand the sampling distribution. And the first one is the normal distribution of the sample means. Sampling distribution is a usually a normal distribution that has a same mean as a population and understand the deviation that equal to the population divided by the square root of the sample size. And what will be the impact of the sampling distribution in the variability? The sample size will affect the variability of the sample statistics. As the sample size increases, the variability decreases. And the standard error of the mean. The standard error of the mean is a standard deviation of the sampling distribution of the mean, which indicates how much the sample mean deviates from the mean of the population. So let us take one example of a sampling distribution. First of all, the first step is the random sampling. So take a large population and randomly select a small sample size. For instance, if your population is all seniors, you can take a sample of 30 seniors. And the step number two is to calculate the sample statistics. So calculate a sample statistics often the mean. For instance, the average GPA of the 30 seniors. And the third step is repeating repeating it multiple times. Repeat step one and the two numerous times to obtain the various sample means. And the step number four is to construct a sampling distribution. Construct a sampling distribution from the sample mean to obtain an idea of the population mean. So let us understand what is this central limit theorem. So the central limit theorem states that regardless of the shape of the population distribution, the distribution of a sample means will be approximately normal for samples of a sufficient size. And what is the importance of this central limit theorem? The main importance is this central limit theorem underpins the use of many statistical procedures in the social science, health science, engineering, and business fields. And what there are some limitations of the central limit theorem. What are those? The central limit theorem requires a larger sample sizes to work, and there are some instances when the central limit theorem might not apply. So how can we solve the problems using the sample distribution? So let us look at it. The first one is normal distribution example. For instance, if the population is described by a normal distribution with a mean of 100 and the standard deviation of a 10, then the probability of the sample mean being less than 95. And the t-distribution example. So for instance, if the population is not a normally distributed but the sample size is less than 30, then a t-distribution can be used in place of a normal distribution. And the confidence interval example. For instance, if a confidence interval gives a range of values where the true population parameter is most likely to lie, like the mean height of the college students in a region. So let us study how this sampling distribution property impacts on the statistical interference. Uh, so if the nature of the sampling distribution property is sample size, As the sample size increases, the standard error decreases. The distribution approaches normality, and the statistical interferences become more reliable. And if the nature of the sampling distribution property is population size, its impact on the statistical interference is, in general, the population size does not affect the sampling distribution, but it can have an impact in a certain cases. And if the nature of the sampling distribution property is sampling design, and its impact on statistical interference is the random sampling or a stratified sampling design to reduce the bias typically produces a more reliable interferences than convenient sampling. So let us conclude this uh, topic by looking what we have discussed earlier. So the first one is we discussed the sampling distribution definition, that is an estimate of the probabilities of the possible values of a statistic as a result of a random sampling. And uh, and then we looked at central limit theorem, that is the statistical theory that states that the mean of the sufficiently large number of the independent random samples will follow a normal distribution. And the third one is the sampling distribution. And the sampling distribution, as we know, is directly affects the statistical interferences based on a random sampling, and understanding it is vital to many scientific fields. So with this, we will conclude this topic. Thank you.